Hi, good evening everyone. In the last class, we solved the problems on minimization type of transportation problem. Okay, today we'll solve the problems on maximization type. Before that, the transportation problem is nothing but it is one of the special type of LPP problem. It is nothing but the linear programming problem in which the goods are transported from one set of source to the another set of destinations. Okay, depending upon the supply and the demand, the goods will be transported, and in this our main objective is nothing but reducing the cost of transportation. Okay, while solving the transportation problem, we are knowing that there are two important steps are there. The first step is nothing but finding out the basic feasible solution. For this purpose, we are making use of the three different methods. One is the northwest corner method, the least cost method, another one is the WAM method. Okay, once you find out the basic feasible solution, then you need to check for the optimality, and the second step is nothing but the optimization of the basic feasible solution. Okay, today we'll solve the problems on maximization type of transportation. Okay, in this the problem is given as a company has factories at which the supply products to the warehouses D, E and F. The capacities of these factories are 200, 300 and 400 units per month respectively. If the overtime production is used, the factories A and B can produce a additional units of 50 and 60 units respectively. The requirements of warehouses are 400, 300 and 300 units respectively for D, E and F. The expected profit per unit for the different combinations of the factories and warehouses are given in the below table. This is the table given. Along with that, the problem says is the profit per unit decreases by rupees 2 and 3 for the factories A and B respectively when they work on overtime. Determine the optimum distribution schedule and the corresponding maximum profit. Okay, this is the given question. From this, first we need to make a matrix. That is, okay, first we need to prepare the matrix. That is nothing but a company has the factories, that is A, B and C will be the factories. It will be supplying the products to the warehouses D, E and F. These are the transported areas where we are supplying the goods, that is D, E and F. Okay, the capacities of these factories are 200, 300 and 400 units per month respectively. Okay, whenever you are having the factories and there are some supply units are there, okay, there must be some supply units. That is, they are saying as the factories are supplying these much of units, that is A will be supplying 200 units, B will be supplying 300 units and C will be supplying the 400 units. If the overtime production is used, the factories A and B can produce an additional units of 50 and 60 units respectively. They are saying that if they are working on overtime, okay, the factories A and B will be supplying the more units. That's why it will be represented with the overtime factories will be represented with the A dash and the B dash. They are supplying an additional unit of 50 and 60 units. That is, A dash will be supplying the 50 units and the B dash will be supplying the 60 units. And next they have said that the requirements of the warehouses are 400, 300 and 300 units respectively for D, E and F. Okay, it is nothing but there are transporting units are there in which their demands are given as 400, 300 and 300 units. It is nothing but they are having a demand of 400 units for the warehouse D, and for the warehouse E the demand is 300 units, and for the F the demand is 300 units. Okay, once you prepare the transportation matrix, now you need to check the total supply and total demand are equal or not. For that, add all the units of the supply and make a sum, and add all the demand and make a sum. Is both the values are equal or not? Okay, in this case we got the total supply value as 1010 and the demand as 1000. Okay, therefore the total supply is not equal to total demand, that is 1010 is not equal to 1000. Okay, hence it is one of the unbalanced type of transportation problem. Now these type of unbalanced problem will be converted to the transportation problem by adding a dummy column or the dummy row with whatever the shortage unit is there, that will be added with the dummy column. Okay, along with that, we are knowing that it is one of the maximization type of transportation problem. Whatever the cost is given in these cells, that will be representing the profit value, but we are always trying to reduce the transportation cost. In such cases, what you need to do is, first we need to convert this maximization type of transportation problem to the minimization type by subtracting all the elements value with the maximum value in the matrix. Okay, in this all these cells, the maximum element is nothing but 24. Okay, once again we need to prepare the matrix by subtracting all these value with the maximum value of 24. Okay, that is, well, subtract all the values from this maximum value, that is from A to D, the element value is 11, the maximum value will be the 24 minus 11, how much you are getting, that is 13. 24 minus 13, 11, 24 minus 17, 7, and as we know that this is one of the unbalanced type of problem, so we need to add a dummy column, okay, whose elements values are 0. Okay, only we are adding a whatever the shortage unit is there, that will be added here in order to make it the total supply and the total demand to be equal. Now if you go on calculating the total supply value, you are getting the 1010, and the total demand value is 400 plus 300 700 plus 300,000 plus 10, this is 1000. Now the total supply and the total demand are equal. Now it becomes as a balanced type of transportation problem. Now you can move it further. Okay, now the same thing as it is, the all the elements of the matrix will be subtracted with the maximum element of the matrix, and the value will be written in the next matrix, that is 24 minus 16, 24 minus 18, 24 minus 14. Okay, I'll write the matrix values directly. 8, 6, 10, 3, 24 minus 24 is 0, then 11, 15, 13, 9, 11, 9, 13, 0. Okay, once you convert this maximization type of transportation problem to the minimization type, okay, now the thing is, you need to do the allocation for this transportation problem. Okay, for this purpose we are making use of a WAM method. Okay, that is a Vogel's approximation method, in which we need to find out the penalties for each row and for each columns. Okay, that is, first we will go with finding out the row penalty. The penalty to be calculated as by taking the difference between the least value and the next least value. In this, if you come to the first row, the least value is 0 and the next least is 7. The difference is 7. And come to the second row, the least value is this and the next least is 6. 0 minus 6 is 6. And in this case, the least value is 0 and the next least is also 0. The difference is 0. And in this, 0 is the first least, next least is 9. 9 is the difference, 0, 9, 9. In the same way, calculate the penalties for each column. In this first column of D, the least value is 3 and the next list is nothing but 8. The difference between the 8 and 3 is 5. 0 minus 6, the difference is 6, and thus in this the least is 7 and the next list is 9, the difference is 2, and in this the least and the next list is 0, 0, therefore the difference is 0. Now once you find out the penalties for each row and column, you need to do the allocation by selecting a maximum penalty value. Either it is from the row penalty or from the column penalty. You need to select a maximum penalty. Okay, in the row penalty we are having the two maximum values, out of which you can select any one. Okay, I am selecting this penalty has the 9. In this particular row, now you need to do the allocation by selecting a minimum least cost value. It is nothing but the least cost will be having this cell. For this cell we are going to do the allocation. That is, it is nothing but just look at the demand here, there is a demand for the dummy column of 10 units, but how much is the supply is there? But the supply is 60 units, but we are requiring only 10 units, therefore 10 will be allocated here and the subtraction will be 0. Then the remaining supply amount is, the unit is 50. Then this particular column will be deleted. Okay, in the same way, once again calculate the penalties for each row and column. Okay, that is, if you come to this row, the list is 7 and the next list is 11, the difference is 4, and in this 6 minus 8, 2, 0 minus 3, 3, 9 minus 13, 4, and in this 9 minus 11 is 2. Come to the column. In this, the list is 3 and 8, 5, the list is 0, 6, 6, and 7 and 9, the difference is 0. As this particular column is deleted, we need not to calculate the penalty for this. Now once again find out the maximum penalty in this case. In this case, the maximum penalty will be the 6. Move on this particular column, select the least cost cell, that is 0. I'll do the allocation for this. Look at the demand and the supply. The demand is 300 and the supply is 400, so I am allocating the 300 here. The 300 goes on and the remaining is only 100. As this is fulfilled, just delete this particular column. And next, once again calculate the penalties of column and rows. This is deleted, and the difference between these two is, as it is 5, and in this it is 7 minus 9 is 2. And for the column, once again you need to calculate the penalties, that is 7 minus 13, that is 6, 8 and 10, the difference is 2, and the 3 minus 11, the difference is 8, and the difference between the 9 and 15 is 6, and the difference between 11 and 13 is 2. Now once again select the maximum penalty here. In this, the maximum penalty is 8. In this particular row, the least cost cell is 3. For this I am going to do the allocation. Just look at the demand and supply. Here the supply is only 100 units, but the demand is 400 units. Just fulfill the 100 units to this and subtract this units from this, and the remaining is 300 units. Now as this is fulfilled, this particular row is deleted. Once again calculate the penalties for this. The difference is 6. In this it is 2. As this row is deleted, no need to calculate the penalty. The difference between the 9 and 15 is, once again it is 6, and the difference is 2. And for the column, the difference between the 8 and 11 is 5, and as this is deleted, no need to calculate the penalty. And for the third column, the difference between the 7 and 9 is 2. And now once again find out the maximum penalty value here. In this, we are having the two maximum value with the same value of 6. Either you can select this penalty or this penalty. I am going to select a penalty of 6 in the first row, and in this I am going to select a least cost cell. This is of 7. Okay, for this I am going to do the allocation. The supply is 200 units and the demand is 300, so 200 will be allocated here. If you do the subtract, okay, 0, and in this 100 will remains, and I am going to delete this particular row. Okay, and once again the same procedure will be repeated, okay, until the supply and demand to be equal. Now in this, the row is deleted, no need to calculate the penalty. In this, 2 is the difference. In this, no need to calculate, and in this the difference is same as it is 6, and in this the difference is 2. And in the column, if you come, the difference is, the least and the next least is 8 minus 11, that is 3, and no need to calculate here and no need to calculate here. The difference between the 9 and the 10 is, that is, the difference between the least and the next least value is nothing but 1. Therefore find out the maximum penalty in this case. The maximum penalty is 6. In this, do the allocation for the least cost, that is of 9. For this, the supply is 50 and the demand is 100. So I am allocating the 50 units to this. This will be subtracted, and from this, if you subtract the 50, the remaining is only 50. As this is fulfilled, this will be deleted. Okay, once again, if you find the maximum penalty, this is the maximum penalty. Out of this, the minimum least cost cell is this. For this, if you do the allocation, 300 is the demand and 300 is the supply. I'm going to allocate the same here. As this is fulfilled, it becomes 0, and this is also 0. Now I'm going to delete this particular column and this particular row. Now the remaining is only the 50 demand and the 50 is the supply. Now if you do the allocation for this particular column and this particular row, the 50 is the allocation, that is 50 supply and the 50 demand. This goes off. Both the column and the row will be deleted. Now all the allocation will be did, and now the total supply is equal to the total demand. Okay, now this is the basic feasible solution after doing the allocation. Now we need to check the optimality. Before checking the optimality, you need to check whether the total number of allocations is equal to m plus n minus 1. Here m will be indicating the number of rows, n will be indicating the number of columns. Okay, the total number of allocations here, it is nothing but, okay, how many allocations we did? This is the first allocation, this is the second allocation, 3, 4, 5, 6 and 7. Totally how many allocations are there? There are 7 allocations, which will be equal to the number of rows. How many rows are there? Here 1, 2, 3, 4, 5. There are 5 rows, plus how many columns are there? It is 1 plus 2, 3 plus 4. 4 minus 1. 7 is equal to 5 plus 4 is nothing but 9 minus 1, how much you are getting? 8. Is 7 is equal to 8. Therefore, the 7 is not equal to 8. It means that the total number of allocations is not equal to the m plus n minus 1. In such cases, a degeneracy will exist. It means that you need to remove this degeneracy by adding an element of epsilon, whose value will be nearly equal to the 0. Okay, once again you need to prepare the matrix. Okay, that is nothing but write down the same values here as it is. Okay, that is with the allocation whatever you did. Okay, that is nothing but I'm going to write the allocations as it is, that is for the A, there is no allocation. From A to E, there is no allocation. From A to F, there is a allocation of 200 units. And from B to D, an allocation of 300 units. I am going to write the same here. And from C to D, an 100 units. And from C to E, 300 units. And from A dash to F, it is 50 units. And from B dash to F is also 50 units. Along with that, there is one more allocation from B dash to a dummy column. Okay, it is of 10 units. Okay, there are totally 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6 and 7 allocations. Okay, these number of allocations will not be equal to the m plus n minus 1. Okay, whenever this case exists, this will be called as a degenerate case. Okay, in such cases, in order to eliminate the degeneracy, we need to add a smaller value of epsilon, whose value will be equal to 0. Okay, that will be allocated to any of the element which will be having the least cost. Okay, in this particular matrix the least cost is 0 value. Out of these any values, okay, you can allocate the epsilon. So I am selecting this element as this is having the least cost of 0, and for this I am going to do the allocation of epsilon whose value is equal to 0, only to eliminate the degeneracy in order to satisfy this particular condition, that is total number of allocation is equal to m plus n minus 1. Now if you look at the total number of allocations, now it becomes, okay, after adding the epsilon to this particular matrix, this becomes the allocation is 1 2 3 4 5 6 7 8. Okay, the total number of allocation is now 8 and the m plus n minus 1 value is also 8. Now you can move with the further step, that is, okay, now you need to check the optimality. Whatever the feasible solution you got, okay, that will be checked for optimality. Okay, for this purpose we are using the Modi method. Okay, in this there are two types are there. One is the UV method, another one is